If you want right. So basically, oh shucks. So we spent some time on the normal distribution, right? So we talked about the normal distribution. I told you that the probability underneath here, the probability is 1, right? It's symmetric about 0, right? This half is 0.5, this half is 0.5. We said that when you're reading off values from the table generally gives you less than. So the probability of z less than a is equal to some value that could be obtained from the table, right? If you got more than, right, that's this small region, it'll be 1 minus the value that you read off, right? It'll be 1 minus the value that you read off, right? And I gave you a list for something negative and something and the between 2 points, right? Yesterday, sorry, not yesterday. Last day we looked at questions where you have to go in reverse. So I gave you the probability of z is less than a is equal to, let's say, 0.7, right? So what that means is this. Because the value is more than 0.5, because the value is more than 0.5, it means that a is on the right side. So a is positive, right? Because this value is more than 0.5, it means that a is on the right side. So it means that a is positive. So in order to get a, all I need to do now, all I need to do is, so they said phi of a is 0.7. So for me to actually get a, I have to go to phi inverse of 0.7. So you go to your table, remember your tables look like this, and you read off 0.7 here. You take this value and that's what a will be. Okay, we did that. And I also remember, if for example, I said the probability of z is less than a, and I gave you something like 0.4, what that means is that a is actually here, negative side, right? So whenever a is on the negative side, we can't get negative values from the table, right? We can't get negative values from the table. So because this distribution is symmetric, we have to do the, we have to get the reverse, right? So this is the same as this. So to get this value, right, is 1 minus 0.4. Then you find the inverse of that. Okay, everything here works. Everything here works. If we have a standard normal, means a normal with mean 0, variance 1. But what happens when that distribution follows a normal of some value mean and sigma squared? What you have to do is something called standardization. So now you have to standardize this and turn it into z. Okay. So for example, if I said to find the probability of x is more than let's say I'm just making up something, right? E, x is more than e. And you have to find this value. You can't get this on a table. So you have to standardize z. So to standardize, you minus the mean and you divide by the standard deviation. So you just square root this, right? And then you go ahead and you read the tables off and say, right? So last day we started to do questions where we were doing these little things, right? So we're going to do 1 or 2, and then we're going to take a look at a new situation, a situation where I'm going to give you a binomial distribution, but because the distribution is too large, we can't use a binomial. Binomial is only when we have small amounts of values, like let's say 15 values, right? But suppose the value goes more than that, then we can't use a binomial anymore. We have to approximate it to this normal here. Right? This is what we're trying to achieve. Yeah, we could go through those things today, right? right? So if right, so just in case you missed some of these things, if you look at the last video, not last class, that didn't record last class, but the one from before, it has some of these things in it, right? But today I want to do a couple of those worded and then we're going to now try. Then we are going to try the last part, right? The approximation. So watch this here. Whoever doing that, stop doing that, please. Right. So let's take a look at this here. Everybody online, so I should be able to see it, right? We did module 1 already. We did all this probability here. Did that already. All right, we got to pull back on that one because that question is yeah, man, we should be able to handle this part here. I'm not seeing any approximations or anything, right? So let's try part C. Right, take a little read. Right, so just to start here, they gave you X. It follows a normal distribution with mean 12 and variance 4. They want you to find the probability of X is more than C is equal to 0.9583. So first thing first, you have to standardize the left-hand side. And then when you standardize, you have to determine where you think the value is. Right? Remember, when you standardize, Z will be C minus the mean all over the square root of 4 with 2. So you have to figure out if this value is positive or negative. It's a more than, right? So what do you think, Kaylin? Is the value more positive or negative? Look at the probability they want, right? 0.9583. Negative. Good job, Kaylin. Thanks for answering to Kaylin. Probably the first time you answer in a few years. Good job, Kaylin. Right, so we know it's minus K and all here, that probability will be minus 9583. So find the equivalent because remember, we can't find a negative value, right? Go ahead. Do all the thing, try and finish this out. Right? So how is negative? Oh, Darian, remember is more than. Right, Darian? I think I tried to explain this to you last time. Remember, it's more than. More than goes to the right. Okay? So if it were positive, the largest value it could possibly be is 0.5. But because the value is more than 0.5, the probability has to include a little bit more. So that is why it has to lie on the negative side. That's okay, Darian? You sure? You will ask us again tomorrow, right? But thanks for coming to class, Dara. And paying attention. And then yeah, heart attack, and I thought all of them going, and I wasn't no clue none of that. Especially because of fun and I couldn't. This man is leaving. Have a new one, have a new slave.
And Bobby.
No, there's why send you everything. Put it back in, right? Oh yeah, finish it up and tell me what you'll get to see. I'll do it in 2 minutes. Right? So the top part is equivalent to K less than, right? So we can leave it like this. Right? So the probability of Z is more than C minus 12 on 2 is the same as the probability of Z is less than C minus 12 on 2, which is 0.9583. So what you have to do now is you will tell them that phi of C minus 12 on 2 is 0.9583. So you have to go to your tables, and find phi inverse of 0.9583. What is that? What is phi inverse, Darian? of 0.9583. 1.731, nice. 1.731. And then finish it up. C is equal to 2 by 1.731 plus. Right, plus 12. How much is that? How much is that? Oh wait, yeah, I forgot to put the minus sign. I'll put that last. 11.83. As well, yeah. Right, so I'm supposed to put the minus sign there. Okay, how you get minus that? So I have 2 by 1.731 minus. I have 8.538. 15. Okay, so it's supposed to use 2 pause, I mean. Right, so initially I was supposed to put a minus sign here, but I didn't, right? I was supposed to put a minus sign here, sorry. On the outside of the C minus 12 on 2. Right, Jesse, you see why it's not 15, right? Yeah. I was supposed to put the minus sign on the outside. I just forgot to put it here. Right, but I put it in now. So it will be minus 1.731 is the value you get from the table. And then solve to C. Any questions online? Do you just follow what I did here? Killing? So your final answer really has to be negative, right? This value supposed to make this thing here negative. Copy it down, let's do the next part. What are you writing? Taking it off, right? Try this one. Try this one here. So they told you is squash harvest follows a normal, they give you the mean and they give you the standard deviation. Calculate the probability that is more than 600, right? That one kind of straightforward, right? Right, then how much expected cheaper price, right? So it's not that difficult, but let's do it still. Let's do it still, right? But we show you can do anything. No, it wasn't here since. Like message answers when you finish. Any answers, right? I mean, I'll work it out just now. Nice. You part it, answer na gawa. You have no answer in terms of the wavelength. So you're minus 7 and divided. Divided by 0.625.
Sorry, it's divided by 6, not 6.6. Because I changed it to meters, but any second.
What's in the wavelength, not that wrong?
No, well, it is meters.
Check about it, look it wrong. What do you mean, the 15 and 9 meters?
No, 15, not in meters.
Oh.
I didn't convert it in units.
Well, whatever. Describe the motion of any of the water particles that are. So what you have to do, that's a half number of wavelengths, right? What does that mean? 2.5 means a half number of wavelengths. So would it be constructive or destructive? When the waves meet, right? And part differences of wavelength or whole number, like 2 wavelengths or 5 wavelengths. When the waves meet, remember you can have constructive or destructive. But when it's a whole number and they meet, it's constructive interference. When it's in between, it's a half number. It's about disruptive. But the particles not moving out destructive. Right, sorry there. So let's see what you end up with, right? So X follows a normal of mean 578 and standard deviation 35, right? Right? 578 standard. So they want the probability that the squash chosen at random from a previous day's harvest is more than 600. So you have to standardize. So that's the probability of Z is more than 600 minus 578 all over 35. That value is a positive value. Right? So that's like right here, right? So that will be 1 minus 5 of whatever that is. Right, so that's 600 minus 578 all over 35. I got 0.6285. What you all got? I see in different probabilities there. Should be something small. 2647. Yeah. Anybody else get that? Where you get that, right? Two, 6, 4, 7. You just hear me say that? Caleb, what's the correct thing? 2, 6, 7. Oh, I didn't see it. Probably higher up. You sure? Not that yet. I didn't see anything. But yeah, I see it now. You use 0.629. Oh, that was bad. Very, very bad. You rounded off too. Okay. All right. Well, let's use that value, right? So we use 0.647.
Please, down here, official. I know it's less. 3 months, huh?
Yeah, you move the same distance.
Okay.
Try this here. Try the next part now to turn it there, right? Right, so when you have how many answers I have there? Two? I have two answers alone. Wait, that's the same person. That's one answer. Thanks, Jesse. Really means a lot. Right? Next part. How many squashes selected are expected to weigh more than 600? Really easy. We know the probability of more than 600. So it will be 50 by 0.2647. Right, so I have 13.2, so therefore well, you can have a 0.2, right? So that might be 14. Hold on, Now 14 not possible, so 13 here. 14 not possible to be more than 600. Right? Okay, so we'll go 13. One more part. Last part. This one looks like we had to work in reverse, right? Or probably. Yeah, we want to find the percent, oh no. Try this last one here. Kaden, you okay with the one from before? Good job, Darian. Try this last one. Last one. Alright, ready? Let's go again. I think any answers, sorry, one answer for this one, two. So squash is less than. Squashes that weigh less than 525 are sold at a cheaper price. What percentage of squashes, of the squash harvest will be sold at cheaper price? So therefore, all we have to do is to work out that, right? So first thing we're gonna do is standardize 525 minus 578 all over 35. That's the probability of Z is less than, how much is that? I have minus 1.514, right? So basically, less than negative is here, is that small value. So the probability of Z is less than minus 1.514. Remember in the summary I sent you all some things, right? So you could also, once you see less than a negative, you know how to get it. So it's 1 minus 5 of 1.54. Sorry, 514. What I get it? 0.065. Anybody get that around that? Yeah. So therefore the answer as a percentage is about 6.5%. I didn't really review the table, I just watched out the value, right? So I hope I'll read it out properly. Okay, so that's the way you do questions like that. Everybody okay with that? Right, I want to show you the last thing one time, right? Because I find people not really coming out to this class, so I feel I want to finish it up today. That's it.
Which one, I,
Gas. Are you okay with that? So I wanted to show you one last thing here, right? Let me see if this whiteboard will work. Any questions on this? Yeah, I get to have. Right, so I want to take a look at this normal thing, right? I want to show you something here. Yeah, graph to show you. Alright, so what is here? So here's what we're doing, right? The next thing that we're looking at is we're looking at the normal. We're looking at the normal approximation. Let's spell that right. To the binomial distribution. Right. So here's what has happened. If you have a few values, right? If you have a few values, just one or two, right? Your binomial distribution might be shaped something like that. Not so normal, right? But as soon as they start getting more and more values, right? As soon as they start getting more and more values, you would recognize that the shape of the distribution looks a little bit like a normal. Why is this not working? Right, sorry. So what that's saying is that as n increases, right, your binomial distribution approximates the normal distribution, right? So that's what it's saying, right? The more values you get, the more it approximates to that. To be specific, right? To be specific, when n is large, or I'll write it somewhere here. When n by p is more than 5 and n by q is more than 5, when those two things happen, right, we can no longer use a normal. Sorry, we can no longer use a binomial. So x will no longer follow a binomial, x will now follow a normal distribution, right? Remember how to get mean, NP, and variance, NPQ. Okay, so that's something for us to remember, right? The normal approximation to the binomial, that's what will happen. Okay, as n gets large. But here's the tricky thing. Here's the real big problem. The big problem now that we have to cater for is this. Let me see if I can change up the color. Right, really important. What type of distribution is normal? Is the binomial? Anybody remember? What type of distribution is binomial? Anybody? What type of distribution is the binomial? Alright, let me make it simpler. Is it discrete or continuous? Binomial, eh? So the binomial is discrete. Good try, Darian. And what type of distribution is the normal, Kaden? Should have space in the back, I think, yeah. It's small, but it should have. Mass creation. Okay, this is about 10 things. It should, but I'm not home. Right, so here's the problem, right? The problem is when you go from a discrete to a continuous, what's the problem here, right? Let's say we had, I'm moving this up, right, in case anybody writes it. Let's say we had the probability of x is more than 5. Wait a minute. Wait. But let's stay around here, right? Because it's 20. No, can't be around upstairs, so we'll can't. Right? So the probability x is more than 5, right? While it was discrete, it might look something like this. It might be 6, 7, 8, 9, and so on. But we have to cater now for it being continuous. So what we have to do is apply something called continuity correction. So we have to consider, suppose there was a value 5.6, right? Where will that value lie? Where will the value 5.6 lie? 5.6, if we round it off, should really fall 5.6, right? Remember, you would have rounded that value off to make it discrete, right? So how do we change this to include values like 5.6 something? Well, what you will have to do is this. The probability of x is more than 5.5. Well, more than or equal to 5.5. What that will do now is that will include values like this. Okay? That will include values like that. Okay? So the probability of x is more than or equal to 5.5, right? You know, I say more than or equal, I can just put more than. All those values will allow it to be, will include all the continuous values. Okay? If you had 5.4, of course, you would have rounded that off as 5, and that would be included. Okay? So that's basically how it will work. Right? What you think about this here, Ravisha? Suppose it was x is more than or equal to 5, right? And I want to apply continuity correction. What will this be? Let's see what Rubina will come up with here. I mean, Ravisha. Hi, Ravisha. I see you moving the mouse and thing there. You might answer now. First time I get an answer from you in how much? For 4 months? Here we get one now. Ravisha. Ravisha. What do you think, Ravisha? What will be the continuity correction? While you're waiting on Ravisha, you all can message what you all think, right? Sir, I panicking, I don't know. Oh, okay. Right? Think about it, Ravisha. You want something that will include all the continuous values. So I'll give you a hint. Right? Because I like you, I'll give you a little hint. I'll give you a little hint. Here's the hint. Here's the hint. Good job, Cassie. Here's the hint, right? More than or equal to 5 will include values 5, 6, 7, 8, 9, and so on, right? So, what do you think x has to be more than? X has to be more than what? To include all those values, all the continuous values. 4.9. So think about it, Kaylin. Where would 4.6 go? 4.6 when you round it off would have been 5, right? Think about it again. Right, very good. So she said more than 4.5. All right, so when you apply contingent correction there, you will get y is more than 4.5, right? Kaylin, you see y is more than 4.5? Try this one now, please. 5 is less than x is less than 8. Apply the contingent correction then. Tell me what you get. Everybody, try it now.
What happened there?
What's that? What again? Jesse, yeah. So in your mind, you should always do this earlier, right? Jesse, check it back before you send the answer. Or check back your answer, guys, send it already. List the values that satisfy, list the discrete values that satisfy 5 to 8. Because remember, 5 not included, 8 not included. So the values are only 6 and 7. Good job, Kaylin. One correct so far, Darian. Hey, Darian's tying 2 boy, 2 correct. Nice. Let me see if Abisha will throw something in. Jesse, fix yours, right? Yeah? Anybody? Anybody else? Right, so only so because 6 and 7, right? Because we have 6 and 7, then the smallest possible value is 5.5. Basically, you're minusing 0.5 from the smallest value and adding 0.5 to the largest value. Right? That's all they're really doing. So that becomes your range, right? 5.5 to 7.5. Okay? So once you recognize you're going from a discrete to normal, you apply contingency correction and do the normal thing after that. All right? So let's try one before we wrap up, right? Last one. Do you think? So first thing you have to do there is tell them it's a binomial, but because the binomial too big, we have to do it approximate and normal. Okay, do that for me then. I know it's a little small, but all of you are online, right? So you should be able to see them.
Oh gosh. Oh gosh. Come inside, come.
Yeah, you're curling with it. Darian, you're muted, you need to mute it.
Go inside.
Darian, you sit down and do your work now. Right, so you should have, the first thing you should have is that, n is equal to 150, p is equal to 0.4, and q is equal to 0.6. Right, so of course, x follows a binomial with n 150 and p 0.4. Right? But if you multiply n by p, you'll get 150 by 0.4, and you will recognize that the value is 60, real big. So that value is more than 5. So we have to change the approximation. So we had to approximate normal, right? Remember how to get mean? Mean is NP. So you're multiplying n by p, that's 75, and then you're multiplying n by p by q to get the variance. Anybody do that? Sorry, that's 60. What's n by p by q? What's n by p by q? What is 60 by 0.6? I have 36, right? So I write in 6 squared. I don't like to write 36 because sometimes you make a mistake and forget to square root it. So I wrote 6 squared. Good. And now they want us to find the probability of more than 55. X is more than 55 out of the 150. So remember, because more than 55 was for a binomial, we have to apply continuity correction. Right? So that would be x is, right? First value will be like 56, right? So x is more than 55.5. And that's it, you're done. Everything else after that is like what you've been doing before. So now you'll get the probability of z is more than 55.5 minus the mean all over the variance. Standard deviation. So you'll get the probability of z is more than, I think that's minus 0.75. Right, remember it's a more than and it's a minus, so it's here. So that's the same as, when it's a more than and a minus, it's the same as phi of 0.75. Go to it tables, tell me where again now. What is phi of 0.75? Check the tables now, where y'all got. Zero point 7734. Okay. And that's it. 0.7734. Right, and that's it. So in these questions, all you have to do is identify that because the binomial is so big, we had to convert it into normal. Right? And most people forget to apply continuity correction. All you have to do is apply that and you're good to go. All right, so we'll stop there for today. Next day, we'll do plenty of questions on this and wrap up. This is the last thing in module 2. Right? So we'll spend some more time on some questions and that's it, right?